Hello. In this lesson, we're going to be doing section 9.2, which is using the sum and difference formulas, or the sum and difference identities, actually, for trig to find exact trig values for sine, cosine, and tangent. So for sine, cosine, and tangent, you can find the exact trig values on a unit circle when they're on one of the angles that we have discussed a million times over, 30, 45, 60, 90, and so on, all the way around the unit circle. However, if it's not on the unit circle and it's sine of 15, then you can put it in your calculator. That'll give you a decimal answer, but it won't give you an exact answer. So instead, we're going to be using the sum and difference formulas of sine, cosine, and tangent. So here we go. So the first thing you have to do is to pick the numbers for sine, cosine, and tangent from, I'm going to write them out. Let's see. So we have, I guess 0, but that's fine. 0 or 30, 45, 60. Usually you don't have to use the 1 on the end. 90, 120, 135. Actually, I don't really need to use 90. 150, 210, 225, 240, and then fourth quadrant, 300, 315, and 330. And you don't usually have to use those. So, in order to get sine of 15, you could use 45 minus 30. You could do 60 minus 45. And you don't really want to add anything here to get 15, so we are going to do sine of 45 minus 30. So we're using this formula. Now, when you do that, then this becomes A and this becomes B. They use lowercase a and b here. Usually it's, well, it depends on what trig formulas you're using, but that's A and B, the 45 and the 30. So that means if I use this formula here, which I'm going to, we're going to have sine of 45, then we're going to cosine of 30 minus cosine of 45 and sine of 30. Again, we're using this formula. And then we fill those in. So if you have your unit circle handy, or if you know these off the top of your head, then we can have the sine of 45 times cosine of 30 minus cosine of 45 times sine of 30. If you work this out, you're going to get radical 6 over 4 minus radical 2 over 4. You cannot add those together, and that will be your final answer. Now, when you're doing tangent is a little tricky because it has a lot of radicals in it. So, and fractions. And because they're on the unit circle for tangent, there are also radical 3 over 3 as some of the answers. You really don't want to use the radical 3 over 3. So for tangent, you only want to use the numbers that are not 30-degree reference angles. So you only want to use these. Excuse me, that's not right. All right, and again, you do not want to use these angles. And the reason why is that tangent is radical 3 over 3 there, and then we're going to have to put a fraction inside of a fraction, and it becomes much more difficult to use. So instead, we will be using the other numbers that are circled up here. Okay? So first I'm going to change this into degrees because it makes it a little bit easier. So I'm going to multiply by 180 over pi. That gives me tangent of 105. So to get tangent of 105, using the numbers that are circled up there, I'm going to go ahead and use 45 plus 60. And then we'll go from here. It is going to take some space, and here we go. So using the formula, we're doing the plus formula, which is this one. We're going to have tangent of 45 plus tangent of 60. It's going to be a fraction. Over 1 minus tangent of 45 times tangent of 60. Tangent 45 is 1. Tangent 60 is radical 3. And then 1 minus tangent of 45, which is 1. Okay, tangent 45, which is 1, times radical 3. So it's 1 minus radical 3. Okay, because we have to multiply these together. All right. Now, everything, and when you do tangents, will always be the same. So we want to get rid of the radical that's in the denominator because you can't have that there. So we're going to multiply by the conjugate of the bottom. The reason we're doing that is to get rid of the radical in the denominator. So in the denominator, you're going to multiply those two together and those two together, 1 minus 3. And then in the numerator, you have to distribute. So it's going to be 1 times both of these. So that's 1 plus radical 3. And then you're going to multiply radical 3 times both of these. So that's going to be plus radical 3 plus 3. Keep going. So at the top, I'm going to have 4 plus 2 radical 3. And the denominators, I'm going to have negative 2. And that will always be the case when you're doing tangent, that you're going to have minus 2 in the bottom. And it will always be the case that in the numerator, you're either going to have positive 4 or negative 4, and negative 2 radical 3 or positive 2 radical 3. Then we're going to reduce all of this. So you reduce them separately. So it's 4 over negative 2 plus 2 radical 3 over negative 2. So when you reduce this, you get negative 2 minus the square root of 3 for your final answer for this. Okay, so tangent of 7 pi over 12 is negative 2 minus radical 3. And sine of 15 was this. Whenever you do sine and cosine, it will be one of these answers that looks like that. Go ahead and try the next two. Okay. So for the first one, we'll be doing the same thing as above, except for we're going to make this sine of 45 plus 30. And it doesn't matter if you put 45 first or 30 first. So sine of 45 cosine of 30 plus cosine of 45 times sine of 30. And you should already know what these answers are because we did them above. So radical 2 over 2 times radical 3 over 2 plus radical 2 over 2 times 1/2. So radical 6 over 4 plus radical 2 over 4. And again, we cannot add those together because the radicals are different. And we can't reduce them because one of the numbers in the radical and one is outside of the radical. For tangent of pi over 12, if you multiply this by 180 over pi is equal to 15. So I will be doing tangent of 45 minus 30, no. Again, for tangent, you do not want to use the 30-degree reference angles. So I don't want to use 30 or 150 or 210 or 330 because they're equal to radical 3 over 3, and I don't want to do that. So I will be using 60 minus 45, and that'll work fine. So we will have tangent of 60. So I'm just going to go ahead and start here. Just for room, tangent of 60 minus tangent of 45, using the formulas up there because we have a minus sign there. And then 1 plus, the top and bottom sign will always be opposite in tangent. So up here, we had a plus and a minus, and down here, we're going to have a minus and then a plus. And then we're going to have tangent of 60 times tangent of 45. So tangent of 60 minus tangent of 45, and then 1 plus, and then you just have to decide if it's going to be positive radical 3 or negative radical 3. So it's 1 plus tangent of 60 times 1. So it's going to be 1 plus radical 3. So again, like we did in the top problem up here, we're going to multiply top and bottom by the conjugate of the denominator. So 1 minus radical 3. So in the denominator, we're going to have 1 minus 3, always. In the numerator, you have radical 3 times 1. Radical 3 times minus radical 3. 1 times 1. And 1 times radical 3. And you should find that your two numeric values are the same sign and your two radical values are also the same sign. If they are not, then something's wrong. Okay? So when you multiply at the top, the two radical values, these two, should be the same sign, which gives you 2 radical 3. And the two numeric values should be the same sign, which is negative 4 in this case. And your denominator should be negative 2, as long as you didn't use one of the 30-degree reference angles to work this out. If you divide top and bottom by 2, so it's negative 4 divided by negative 2, that's 2. And it's negative 2 divided by negative 2, which is 1. And for some reason, I can't write radical 3. And it should make sense that tangent of 45, or excuse me, 15 degrees is positive because it's in the first quadrant. Where in this one over here, it was negative because it's 105, and 105 degrees is negative because tangent's negative in quadrant 2. For example 2, they give us a formula to use and they give us some information, and then they want us to find a certain value. So there are two angles, A and B. They want us to find cosine of A minus B, which are the two angles that they're talking about. So first I'm going to write the cosine of A minus B formula, which is cosine of A, cosine of B, and because that's minus, this one is going to be plus. And then it will be sine of A and sine of B. Not sib, sine of B. Now that comes from the formulas. And again, you should have the trig identities handy so that you don't always have to go back up and refer. You should have them on their own separate page. We are doing this cosine formula right here. So you can see that the formula in the formula is minus, and then in the identity, and then outside, when we're actually solving it, will be a plus sign in between. So here's some information that we know. When you're doing these problems, you should draw yourself a picture for A and B. So the first thing that they tell you, this is actually telling you that angle A is between pi and 3 pi over 2. The only reason you need this is to let you know that your angle is in quadrant 3. That's it. You don't need that for anything else. Cosine of A is negative 4/5. I can actually even fill that into my formula. That means that A is negative 4 fifths, and that's A. Actually, that's A, but A is finishes in quadrant 3. Now, because this is a right triangle, then you should know that this is negative 3, because it's a 3, 4, 5. You can also do the Pythagorean theorem, 4 squared plus y squared equals 5 squared, and that's negative 3. They're both negative. In the actual triangle, it's 3, 4, 5, but you get the idea. So since sine is y over r, then sine of A is negative 3/5, and I'm going to go ahead and put that into the formula as well. So next, we're going to deal with angle B, and angle B will also be a fraction. They already tell us that sine of B is 5/13, which means cosine of B will also have a 13 in the denominator because it has the radius in the denominator. This is telling you, and you can use the same picture if you want. I usually like to use different pictures, but it will be going from 0 to pi over 2. That's 0 to 90, basically. So that means that you're in quadrant 1. For angle B, when you were in quadrant 3, for angle A. I don't know if I said angle B or something else because I misheard myself. Anyway, sine of B is 5/13. If you do Pythagorean theorem, you're going to get 12 for the x value, which means that cosine will be 12 over 13 because cosine is x over r. And now we have the numbers over here that we need, and we will just multiply those together. So when you multiply these two together, you will get negative 48 over 65. Do not reduce that. Even if it reduces, you don't want to reduce because right now both fractions will have the same denominator, 65. And so even if that was like another number, again, at the top and bottom that would reduce, you don't want to reduce that until after you're done. So when you add these together, you will get your final answer. So if I combine these, I will get, let me just, I'm going to go this direction. When I combine these, I will get negative 63 over 65. And that is the answer to the original question, which is, what is cosine of A minus B? Which is negative 63 over 65. Therefore, we know that A minus B, if you were to take the two angles and subtract them, okay, this is B over here. If you take an angle in quadrant 3 and subtract quadrant 1, most likely you're going to end up in quadrant 2. Not necessarily, it might still be in 3, depending on how big. Like really, you could have 240 and subtract 20, and you're going to still be in the third quadrant. But that's the answer. Please try number 2, same method. So the first thing you should have done is to write down the formula. So for cosine of A minus, without any numbers at all. So write the formula. This will be cosine A, cosine B, plus sine A, sine B. You will have fractions for these. They do give you 2 of them, so if you want, you can start. Cosine A is negative 12/13. And Sine of B is 3/5. Okay, so let me go ahead and do A. A is from pi to pi over 2, or pi over 2 to pi, I should say. This is in quadrant 2. So for A, we're in quadrant 2, and we have negative 12/13. If you do Pythagorean theorem, that makes that 5, and it's positive 5. Again, this is A. That means cosine is, if cosine is negative 12/13, then for sine it's 5. And make sure you indicate which one's A and which one's B. This is angle A here. For angle B, this is quadrant 1. So for angle B, I am in quadrant 1. And it's 3/5 for sine. Using Pythagorean theorem, that means that the x value is 4, which means cosine is 4/5. If you multiply these together, you get negative 48/65 plus 15/65, which is negative 33/65. That's the answer to cosine of A minus B. For the next problem, we will use the formula again. So this is a cosine of two things. We're not going to put any numbers in here. We're just going to try to simplify this as much as we can. So we'll be using cosine of x, cosine of pi, minus sine of x, sine of pi, using the formulas, the trig identities given above. Cosine of x does not have a value. Cosine of pi is the same thing. Pi and 180 are the same. So cosine of pi is negative 1. Sine of x does not have a value. Sine of 180 is 0. This gives me negative cosine of x minus 0, which is negative cosine of x. So we're just simplifying this. Please try the next problem. Same thing. I wish they would have given you sine, but we have, write the formula first, cosine of x, cosine of pi, plus sine of x, sine of pi. So it's the same thing as above, cosine of x times negative 1 plus sine of x, also times 0, which is negative cosine of x plus 0, which is negative cosine of x. Please do the next 8 problems while you pause the video and circle your answers for as many of them as you can and write them down. I will try to put some questions inside the video if I can do that on Edpuzzle. Okay, so for number 1, we have sine of 105. So that would be, for me, I will use 60 plus 45 degrees. I will write the formula out. Sine of 60, that's the wrong formula. Sine of 60, cosine of 45, plus cosine of 60, sine of 45. You need to make sure you use the right formula. So for sine, it's sine cosine plus cosine sine, as long as that's a plus. These two will match up. So the sine of 60 on the unit circle, and then cosine of 60 is 1/2. If you multiply these together, radical 6/4 plus radical 2/4. And again, I will go over these a little bit faster because we've already learned this, and you can slow down the video if you need to. For the second one, for cosine, I will be using cosine of 45 minus 30. And remember, for sine and cosine, it does not matter which angles you use. That only matters for tangent. And again, it matters just to make your equation easier. You could use whichever angles you want for tangent. For cosine, it will be cosine of 45, cosine of 30. And the angle, so we use cosine, cosine, but then it will be plus in the middle because it's minus to start with in my formula. And we will have sine of 45 and sine of 30. When you work this out, radical 2 over 2, radical 3 over 2 plus sine of 45, radical 2 over 2 times 1/2, which will give you radical 6 over 4, plus radical 2 over 4, which is exactly the same answer as the last one. For the next problem, for tangent, again, you do not want to use these angles because they will make your life harder. So do not use 130, 150, 210, and 330 because you will have radical 3 over 3 as an answer, which you don't want for that. So the first thing, I'm going to change this into degrees. It'll make it a little bit easier. So multiply by 180 over pi. That gives you 75. For 75, I do not want to use 30 plus 45. I do want to use it, but it will be harder later, so I will not use it. So instead, you can try to see the other angles that are given to you besides those and see if you can come up with how to get 75. So again, you can use 45, 60, 120, 135, not 210. 240, 225, 300, and 315. I will be using these two. So I will be using 135 minus 60. There are other ways to do this, but those are the ones I've chosen to use. That will give me tangent of 135 minus tangent of 60. Again, I'm using the identity at the top or the formula, plus tangent of 135 times tangent of 60. Next will give me negative 1 minus radical 3 at the top, because this is negative 1, this is radical 3. And then in the denominator, this will be 1 minus radical 3, because it's 1 plus negative 1 times radical 3, which is 1 minus radical 3. So remember, these are multiplied together and you have to do that first. So don't do 1 minus 1. I need to multiply to get rid of the radical on the bottom. So 1 plus radical 3. You're multiplying by the conjugate of the denominator. So in the bottom, 1 minus 3. Denominator. In the numerator, negative 1 times both of those. So negative 1 times 1 and negative 1 times positive radical 3. Then negative radical 3 times 1 and negative radical 3 times radical 3. This gives you negative 4 minus 2 radical 3 over negative 2, which is 2 plus radical 3. So regardless of which numbers you used at the beginning, you should still end up with 2 plus radical 3 at the end. For pi over 12, if you multiply by 180 over pi, this should give you 15 degrees. So cosine of 45 minus 30. Cosine of 40, and again, you can use other things, 60 minus 45. You could do 135 minus 120. There's a lot of different things. Cosine of 45, cosine of 30 plus sine of 45, sine of 30, radical 2 over 2, radical 3 over 2, radical 2 over 2, 1/2. It gives you radical 6 over 4 plus radical 2 over 2. And yes, those answers seem to come up a lot. That's just the way it is. For the next problem, for sine of a minus b, first I will write the formula down. So sine of a cosine of b minus cosine of a sine of b. They give me sine of a. And they give me, let me use a different color, cosine of b. So I actually already know the first one will be negative 192 over 425 for the first fraction. So for the second fraction, I definitely know because for a, for sine of a, we have 17 in the denominator. So for cosine of a, we're also going to have 17 in the denominator. A is in quadrant 1. So if I draw that, I will get 8, 17, and that will be 15 if you do Pythagorean theorem. So this will be 15 for cosine A. For B, B is in quadrant 3. I'm just going to use, well, I won't use the same picture. I will use the same picture. So for B, this is negative 24, negative 7, and 25. So therefore for B, sine will be negative 7 over 25. And if I multiply these two together, this will give me negative 105 over 425. And again, I could reduce those, but I'm not going to. This minus and this minus become plus, and that gives me negative 87 over 425. And that is the answer for sine. The reason I'm going over these faster is because I'm assuming you went over them first. Again, you can pause it if you need to. For number 6, sine of x, cosine of pi, plus cosine of x, sine of pi, which will give you sine of x times negative 1, plus cosine of x times 0, which is negative sine of x plus 0, which is negative sine of x. For the second one, cosine of x, cosine of 2 pi, plus sine of x, sine of 2 pi. Again, find the right formula to use. Cosine of x, cosine of 2 pi is the same thing as cosine of 0. And sine of x and sine of 2 pi is the same thing as sine of 0, because 2 pi and 0 are in the same place. This will be cosine of x plus 0, which is cosine of x. For number 8, we have tangent, which we haven't done this yet, but it will be tangent of x minus tangent of pi. And 1 minus tangent of x times tangent of pi. So this will give me tangent of x, tangent of pi is 0. So 1 minus tangent of x times 0. So at the top, we have tangent of x. At the bottom, we have 1 minus 0. So we have tangent of x over 1, which is just tangent of x. For the last two, we are actually going to solve this equation. So we will use the trig identities that we have learned to solve these. So what we have for the first one, and they look like they're similar. They look like they're, you can almost add these together, but you can't because one's plus and one's minus. So I am going to color code these. So this is what I'm going to do in red. This will give me sine x, cosine of pi over 3, plus cosine of x, sine of pi over 3. Then we have the plus sign in the middle. Then I will be doing this part using the formula. Sine of x, cosine of pi over 3, minus cosine of x, sine of pi over 3. Then we have an equal sign. And then we have a 1 on the other side. Let's simplify these out. So this will give me sine of x. Cosine of pi over 3 is 1/2. Then we have cosine of x. And then sine of pi over 3 is radical 3 over 2. Pi over 3 is the same thing as 60. Plus sine of x. Again, cosine of pi over 3 is 1/2. Minus cosine of x, and sine of pi over 3 is radical 3 over 2. And that equals 1. Let me simplify each part. So this will be 1/2 sine of x plus radical 3 over 2 cosine of x plus 1/2 sine of x minus radical 3 over 2 cosine of x equals 1. These two values right here are going to cancel. One's plus and one's minus. The next two, we'll add these two together. 1/2 x plus 1/2 x, or 1/2 sine x, excuse me, plus 1/2 sine x just gives me 1 sine x is equal to 1. And so what you're trying to figure out is you're trying to figure out where does sine equal 1, and sine equals 1 when x is equal to 90 degrees. Because that's sine of 90, that gives you 1. So that's your answer, or you can actually say pi over 2, because if it's in radians. So this is in degrees, and this is in radians. And sometimes, most of the time actually, there will be two answers, because there are two places, but there's only one place on the unit circle where sine x is equal to 1, and that is at 90 degrees. If you wanted to do it mathematically, you can also do inverse sine on both sides. For the last problem, same thing. You should try it first, please, and then I'll go over it with you. Okay, here we go. Same thing, I will write the formula first and then fill in everything. So cosine of x, cosine of pi over 4. I'm doing this part. Minus sine of x, sine of pi over 4. And then we have a plus sign. And then we have the second part here, which will be cosine of x, cosine of pi over 4, plus sine of x, sine of pi over 4. And we have equals 1. To work this out, we start filling in the values. So we have cosine x times radical 2 over 2 minus sine x times radical 2 over 2 plus cosine x times radical 2 over 2 plus sine x times radical 2 over 2 equals 1. So for this one, we have radical 2 over 2 cosine x minus radical 2 over 2 sine x. The radical 2 over 2 is the coefficient, plus radical 2 over 2 cosine x plus radical 2 over 2 sine x. Again, we have 2 that will cancel out. So these will cancel out because they are the same, but opposite signs, so those cancel. Now, when you have radical 2 over 2 plus radical 2 over 2, that means you have 2 of those. So what you have when you add those together is you have 2 radical 2 over 2's cosine x equals 1, those will cancel. So you have radical 2 cosine x equals 1. So I will divide both sides by radical 2. So cosine x, let me write this a little bit neater. I will divide by radical 2. That gives me cosine x equals, and I'm going to simplify this out. Cosine x is equal to radical 2 over 2. And then you need to figure out at which angles cosine x is equal to radical 2 over 2. So there are two places where cosine x is equal to radical 2 over 2. At 45 degrees and at 315 degrees, which is the same thing as pi over 4 and 7 pi over 4 for x. Now, if you went back to the beginning, they tell us that x is an answer from 0 to pi. So that means that we only get to pick an answer in this range. So we have to pick the 45-degree answer, which is the same thing as pi over 4 if you're writing it in radians. Degrees, radians. And that's it. So hopefully you understood how to do those. We'll go over questions if you have them during the week.